we were speaking about trig equations. Put that in the chat. What do you remember from the last lesson? What was helpful from the last lesson? What were your main takeaways, or what things can you remember from the last lesson? Pop it in the chat. And let's go to Khotso. What do you remember from the last lesson?
We learned how to sketch the graphs using our calculators.
Okay, so we were sketching trig graphs and we used the calculator to help us. Can you remember what changes or what things we learned about in terms of changing the basic trig graphs?
We learned how to change the I don't remember very well.
Okay, we're going to move on to Angela, but thank you, Khotso. That was a lovely start. Angela, let's go to you. What did you remember about the last lesson? What changes to the trig graphs did we learn about?
Mr. S, her audio is not connected.
Ah, okay. No problem. So I will remind you, unless somebody else is willing to share, we learned about if we have a number in front, so we'll call that thing A. We learned about if we change that, we can change the amplitude of the graph, how high or low graph would go. So we learned about the A, or the amplitude change, and then we also learned about if we shift the graph up or down, and we called that letter Q. We learned how the number in front of the graph moves the graph up. Well, that's Morgan. So Morgan, what the number in front does, or the A, is it stretches it vertically. So it stretches it both up and down, whereas the Q simply shifts the graph up or down one way or the other. So give me a thumbs up if you remember the stuff from the last lesson. And give me a thumbs down if it feels very, very shaky. And you're like, oh, I wouldn't mind doing a little bit of revision now. Okay, well, let's just do one bit of revision before we move on to the next one here. If I said to you, let's try together. So we've got this graph here, and I'm going to say to you, draw a trig graph. Let's make it cos, and I'm going to change two things with this graph. So I'm going to put a 3 in front of it. So the amplitude is going to be 3, which means that normally the graph goes between -1 and 1. Now it's going to go between 3 and -3. And what's more, I am going to shift this whole graph down by 1 unit. And we are going to sketch this graph on the domain 0 to 360. So calculator up in a second, but I want to, before I bring the calculator up, can you try and see me using what we learned to the last lesson, noting that when there's an amplitude change, everything's been stretched up and down by 3, and then there's also a vertical shift downwards. See if you can do that. You should see my friend the calculator there. And I'm going to type in there 3 cos x minus 1. Okay, I'll stop there for a second. I'll give you some more time to finish it before I go and do the next bit. And I want you to draw your graph in here. So I've made some dots. We can even put them here if we want. And so if I wanted to draw this graph, that's what it would look like. And we should always label the turning points. So that would be 180 minus 4. We label the end point. So that's 362. And we should also label the graph. So in this case, let's call this graph F. So then it'll be the graph F. And so this is a graph that has both its amplitude changed and it's been shifted down by 1 unit. And this is how we would draw it. Give me a thumbs up if that feels still familiar to you and it feels like you can do it. Give me a thumbs down if you feel unsure about how to do that graph. Okay, fantastic. All right. Well, then let us move on to some other changes. Today, we're going to learn about other changes that we can make. And instead of worrying about amplitude and thingy changes, we're going to talk about what happens when we change the number in front of the X. So this is a different type of change. And I want to ask, who would like to have a go at explaining either over audio or over chat, what effect does putting a number in front of the X or the input have on a graph? Who thinks they know what effect that has before I go to the calculator? What type of change is that called? Put your hand up if you feel like you can give us a tip. Otherwise, you can put it in the chat. What do we think that number does? It's definitely not an amplitude change. It's not in front. It's not a vertical shift. So what do we think this 3 does? So any ideas? I'm looking. So we say that it changes the period of the graph. Now, what would the normal period be of the sine graph? The normal period is 360. What is the period of this graph that has had the period changed going to be? So what is the period of F, which is the one in this case? Who wants to have a crack at this? Who wants to be all they can be? Okay, so all that we do is we do something to 360, which is the original, and we change it using the 3. Yes, Annie, it's 120. But the new period is 120 because we divide 360 by 3 and we get 120 degrees. So we basically just take the normal period and divide by whatever the number is in front of the X. So now what we have is a full cycle of the sine graph will happen in 120. So since my domain is 0 to 360, how many complete cycles of the sine wave are we is going to fit in this domain? Well, we're going to fit 3 because 120 can go 3 times into this line. Okay, and I'll show you that in a moment. But now our step size is also going to be affected. What is the step size going to be for this graph? Based on what we saw in the last lesson. So the period's 120. What's the step size going to be for a sine graph when the period has been changed like this? So I see Annie and Morgan have got, okay, exactly, Annie, it's going to be 30. And the reason the step size is now going to be 30 is when we draw the sine graph, we draw it in like 4 little movements, each one for a step. And because the period's 120, the new step size is just going to be 30. Okay, so it's time for us to draw this out. So I'm going to give you a chance to do it. You're going to go to your table and you're going to put into your table function, you're going to put this equation. The calculator knows already what graph is going to be there. Your beginning is going to be at 0, your end is going to be at 360, and your step size is going to be 30. I'm going to give you 2 minutes to try and draw the graph for me. and then I will come along and draw it with you. And make those little dots as you go so you can. And if anybody's unsure about what to type on the calculator, please do ask us in the chat or raise your hand and we will gladly assist. I know this is still new to a lot of you. So I'll put here sine. Then I'm going to put a 3 alpha x and then close. Let's go with red. And then 30 is going to be this, and 30, and then it's going to be 1. And then 60 is going to be 0. 90 is going to be -1. And then 120 is going to be 0. And then I think I know what's. So I'm getting my dots coming out like that. And that actually makes sense to me because it's going between 1 is the highest value and -1 is the lowest value. And that is the range of the normal sine graph. All that's happened is it's been compressed horizontally. And so when I draw this graph, it should look like that. Now, I haven't labeled all these points. Just because of time, I'm not going to do so, but it's not too hard. And that's all a period changes. It's just basically a whole cycle will now fit, instead of fitting in 360, a whole cycle of the sine wave fits in 120 degrees. So you can see there's the first cycle, there's the second cycle, and there is the third cycle. Give me a thumbs up if that makes sense to you. So do we type it down as sine 3x or just sine x? So Annie, what you do is you type it as sine 3x. So I'll do it again with you guys. So mode, table, so you type sine, and then you put a 3, and then you go alpha x, and then you close the bracket. So that's step 1, so that I get the same thing that I've got here. Then I go equals. I go equals again because there is no second function. And now I'm going to start. And the start is 0. And the end is 360. And the step size is 30. And now I go equals. And that's where I got my red dots from, which give me basically my sine graph where the period is changed to be quicker. Now, we're going to do the same idea again, but I'm going to change the graph slightly. So I'm giving you a new graph called the g of x, and I want you to draw this on the same set of axes. And this graph is just going to be 2 sine 3x. And I want you to draw that for me on the domain 0 to 360. Give me a thumbs up if you feel like you understand what we're trying to do in this next question. So you're trying to draw the graph that I've just done in blue. Give me a thumbs down if you literally like, listen, I don't even understand what this guy is asking me to do. So thumbs down if you don't understand. Thumbs up if you know what I'm trying to ask you to do for the second part of the question. Okay. I would encourage those of you who are feeling uncertain, just pop your hand up and we can have a quick little audio chat. It's sometimes much quicker if we have an audio chat, whereas those who are feeling comfortable, you can start trying to draw the graph G, which has 2 changes, and see if you can predict what you think is going to happen when there's a 2 in front and then a 3 here. And then we'll talk about that, what it looks like in a moment. So there's quite a few students are feeling confused. I'd love to have a chat to one of you. Why don't you just pop your hand up and we can talk about where I'm losing you. So step 1 is I want you to go to your calculator and click on the table. So for those who are feeling confused, we're going to do this together now. Get your calculator and let's follow along. So I'm going to type in here, even though I'm calling it F, I'm going to type a 2, and that's for this 2 here. Then sine, then 3, then alpha x, then close that. You must close it. And now I've got exactly the same thing that the question is asking me for. I'm then going to go equals, and equals again. Now, where do I look for my starting size? I look here, which is 0. So I type 0. Where do I end? I end at 360. Now, here's the interesting question. What is my step size going to be for this blue graph? What's my step size going to be? Put it in the chat. I want you to put your money where your mouth is. What is the step size going to be for this type of graph? What would affect the step size? Yes, it's 30 degrees because the yellow 2 in front only affects how high or low the graph goes, whereas the 3 affects the period of the graph. And so the step size is going to be 30. And so I'm just going to say, okay, my step size is 30 degrees. And I'm going to put that in my calculator. So step is, 30. And then I'm going to get this table. And now I want you to take that table and try and put some dots on the on your Cartesian plane so that you know kind of how that is. See if you can get it to work. Let's take some time to do that together. So 0, 0 is still the same place. And then it goes to 30 and 2. So let me put in some more. There's 2, 3, 4. Now I haven't folded them, but you can see that's 30, that's 60, 90. The increments are in 30. So 60, 0. 90 minus 2. 120, 0. Okay, so the dots at least are looking a little bit predictable here. What do you think is going to come next after 120, 0? We get 150 and 2. 180 and 0. 210 minus 2. I feel like I'm seeing the pattern now. Can you see the pattern? How it's almost like I don't even need to use my calculator because I can see where the jumps are going. Yes, I see, Morgan. You have seen the pattern as well. And this makes sense because trig graphs are periodic, right? So every 90 degrees, or not even every 90, every 30 degrees here. And what I love about this is you can see that the blue graph, the only thing that's different about the blue graph compared to the green one is, can you see that the blue one goes up to 2 and down to minus 2? Whereas the earlier one, it only went up to 1 and down to minus 1. So my follow-up question to you is, for the graph G, what is the range of the graph G? So what is the range of G? And I want you to answer in the chat or put your hand up or whatever floats your boat. What is the range of G? Pop that in your. So I think the highest value is 2, the lowest value is -2. And the way I could write that is like that, or I could write it like that. And that would give me the range of the graph, or that could be it. So, yeah. I think I'm liking what I'm seeing, and I think I want to squeeze in one more before the break. So, your final question before the break is, I want you to draw me the graph of sine y equals sine 2x if the domain is going to be from -90 to 180. And I want to let you fly solo and see if you can work out. Now, I will give you one hint. You only have to go from here to here. See if you can do the working out to draw that graph. And then we're going to take a break.
Go for it, guys.
The calculator is a very good friend in this area if you know how to use it properly. Oh, hold on. Oh, it's sine 2x. And then this one. Okay. Give me a thumbs up if you were able to do that one by yourself. Give me a thumbs down if you weren't able to do that one by yourself there. The only thing that changed in this graph is the 2. And we say that the 2 in front halves the period to 180. And then the other thing that was a bit tricky was instead of going from 0 to 360, we went for a different domain. We went from -90 to 180, which was kind of like a little bit awkward. Okay, so we're not quite there. Some students, we're sort of getting there, but we're not quite there. So we're going to carry on after the break, practicing. But I think for now, we have to give our bodies a break, as we have done a lot of work today, and we want to give ourselves a chance just to rest for a second. So I want everyone to turn your cameras on, and then I want you to stand up with me as we just take a moment to unwind. And let's just stand up for a second.
Please turn on your cameras, guys. Let's see your lovely faces.
Yes, I want to see the people of my class. I want to see my... Okay, stand on your tippy toes and try and touch the sky. Oh, you can feel my stomach muscles. Okay. And then what I want you to do is see if you can lean over to the side. Oh, this is awkward. And then see if you can lean over to this side. Okay. Oh, I can feel things getting stretched out. That's good. Okay. Let's do the tricep stretch. Do that. And then I want you to just shake out your arms. So shake them out. Shake out your arms. I want you to shake out your legs. Do that. And what else should we do? Let's do this one. Stretch that out. Let's stretch out this one. Okay, now heart rate. I think it's cold, and so I need to do some jumping jacks to warm up, and so you can join me. So the way a jumping jack works is you go up to here and down again, and we are going to do 15 of these. So we're starting in 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 10, 12, 13, 14, and 15. And I'm sure your body will be starting to feel a bit more human now. Let's go to a little brain break. So here are our Maths 24 puzzles. See if you can figure out any one of these. The way it works is you have to use all 4 numbers on a card to make 24 using just the basic operations. So over to you guys. I know I'm feeling awake and alive.
The brain juices are flowing now.
I mean, it feels like a cliche, but it's just, there's some truth to this idea that our brains and our bodies are connected. I can't believe it. It's ridiculous.
Yes.
Okay, who's going to get the cards first today? Eight, 8, 6, and 1. How do we get to 24? That's a sneaky one. How do we get to 24 using 8, 8, 6, and 1? We always seem to be trying to get like 8 and 3, or 6 and 4, or 12 and 2. So ask yourself, can you get to those types of numbers? Okay, so Annie has suggested 8 times 1 plus 8. But Annie, it's not a 9. This is a 6 because the line is at the bottom. So that's a 6. You have 8, 8, 6, and 1. I was thinking, what about if I subtract the 6 from the 8 and it gives me 2? Neo has said 8 plus 7, 1 plus 7 plus 8. We don't have a 7 on the card, Neo. Chuma has said 8 plus 6 plus 1. 8 plus 6. 8 plus 6 plus 1, which is 15, plus 8. That gets us to 23, which is close, Chuma, but it's not quite 24. Okay. Anybody else have an idea? 8 minus 6, 2 times 1. Oh, Sechaba, I'm very close to you. I was thinking 8 minus 6 is 2. So I've used up that one. And what if I go 2 plus 1 is 3? How do we get to 24 from there? So I was thinking then all we do is we go, what have we got left? We've got an 8 left. And yeah, Mdudu, you just go 3 times 8 to get us 24. And then we're good to go. All right. I'm going to leave it at that stage. I'm not going to push it too much further, but it's always good to keep working on our Maths 24 skills. But let's head back to our lesson now for today, where we were learning about using our calculator effectively for drawing graphs. So how about this? I'm going to do one more with you. I want you to draw the graph of y equals cos 3x for the domain. We haven't done this one already, have we? Let's have a look. 3 cos, no, we haven't done this one already. Yeah. So I want you to draw cos, let's do these two actually. Let's do these two. I want you to draw cos 3x, and then I also want you to draw tan a half x for that domain. So I'm going to give you quite a bit of time here. First of all, do this one. And then you're also going to do this one down here. And the way you're going to do it is your calculator is going to be your friend. And I want to encourage you to ask questions if you need help while we're doing this. I want to start to hand over the control to you guys. Who has a question? Oh, I see. There's a bit of a delay. I see Mbali and Zanele also got the 24 question. So what's the step size going to be? It's just going to be that. Now, what is my graph going to look like of y equals cos 3x? Are there any questions about how I use the calculator? I'd love for someone who, if you're unsure, for you to come on and then we can actually work through it on the calculator together. Otherwise, I'm going to assume you're okay for now. But yeah, Kwezi, let's unmute you. Can we unmute Kwezi and then we can have a discussion?
Hi, sir. Can you hear me?
Yes, loud and clear. How can I help?
Okay. Sir, I don't understand the starting and the ending, how to put that in the calculator.
Okay, so first of all, Kwezi, are you okay with this number over here, this 0 to 360? Do you know what that means?
Yes, I think so.
Okay, so that's going to be your start. Your start of drawing is going to be at 0, and your end is going to be at 360. So when we put that into our calculator, you can even write here, start 0, end 360, and then we've got this thing called the step size. How do you feel about finding the step size?
Oh yeah, I understand that part, sir.
Okay, so you've got your key numbers. So now what's left is to put this in your calculator. So we go cos. Now I then go 3, and then I have to hit the alpha button so that I get the x to come out, and then I close it. How are you with that bit?
Good, sir. Thank you. Yeah.
Good. Okay. So we go equals. So start was 0, then equals, the end is 360, and that was given in the question, and then the step size was 30. And then I go equals, and I get this table. Now, do you know, Kwesi, how to get the table to the graph where it says 0 for x1? The very first point is going to be here. Are you okay with that point? Don't know if you can still hear me.
Please say that again. Sorry.
Okay, so if you look at this table, can you see this? It says point 1, x is 0, and f of x is 1. So if we look at the scale,
Yes, sir.
scale goes up to 4 like this. Okay, let me draw in the scale. So the very first point is this black dot. The second one, 30, is going to be over here. Like, I haven't put all the values in, but you can see the scale is going up in 30s. And so my second point is going to be 30, 0. So it's actually going to be this dot here. And then the next one is 60 minus 1. And then I have to move this down to help me. So I get 90, 0. And then I get 121. Move down a little bit, 150, 0. So Kwesi, are you following how I'm reading off like a horizontal line, which gives me a point, and then that gives me these black dots here? Are you with me?
Yes, sir. It's making so much sense now.
Okay, that is why I'm here, to help you out. Thank you for your question, Kwesi. Much appreciated. So,
Thank you, sir.
cool. So basically, we're going to draw this, and you know what? I'm getting so comfortable with this. I kind of can see where this pattern is going to go. You can see it's kind of predictable. It's going like this. And so to be perfect, I should be labeling all these points, but we've got limited time, but that's going to be the graph of y equals cos 3x. Okay, now, what about, I want to give you some more time for the graph of tan. And this is going to be a little bit more exciting because tan has that little bit extra. So over to you guys. Yes, Morgan and Michelle, I see you guys in the chat there. Annie asks, sir, why did you make the 360 if the new period is 120? Okay, so if the domain can be as long as you like, Annie. So it could have said 0 to 120, but this question said 0 to 360. And so we fitted in 3 full periods of the graph, and that was just a choice I made. This could have been minus 180 to 180. It doesn't matter. It kind of belongs to the teacher as to decide what domain they want to see. Okay. Now, the tan graph is a bit different. So the normal tan period, the normal one, is 180. But this graph has been changed. So it's going to be 180 divided by a half, which gives me 360 degrees as the period of the tan graph. Now that is interesting because we're quite used to tan graphs having a period of 180, but how will that change things? And we have a choice for the step size as to how many. You actually could make it 2 things. What would you guys make your step size for this question? You could, and the step size just basically gives you points however often you need them. So there's not, sometimes can be more than one solution. So the period is 360. Look, I think it's nice. You could divide it in 2 and just have divide by 2, and that would give you the halves of the tan graph. But I quite like having a few more points. And so you could divide it by 2 and get the step size, or you could make the step size divided by 4, and then your step size would be 90. It actually, both of those would be correct. It's just a question of how often you want a dot on your trig graph. And because I want a few more dots, if I don't have enough dots, and I don't know what's going on, I can make my step size even smaller. And that's a choice I make based on what makes my life easier. Traditionally, the tan graph is only drawn with 2 halves, but it doesn't mean you have to have a step size that occurs in divide by 2. Let's see what this looks like if I tan and then 0.5 alpha x, and it goes minus 360 plus 360, step size 90. Now there's some errors. What are the errors? Who thinks they know what the errors are? Who feels, have I made a mistake, or is that predictable? It's the asymptotes, yes. So there's an asymptote at minus 180. And I could scroll down in my calculator, but because I understand that the period of this tan graph is 360, the asymptotes are just going to be 360 degrees apart. You'll see another error come up later. But, you know, essentially that is, so at the moment, what you notice, let's have a quick look here. So we have, so 0, 0. Let's put the dots in. So minus 360, 0, minus 271, and then an error. So that bit's going to look like that. Minus 90, minus 1. And for those who are feeling confused, remember there's a scale here. Hey? There's a 1 there, a minus 1 there, minus 2, 2, 3, and so on. Then I've got, so it's minus 90 minus, I made a mistake, sorry guys. Minus 90 minus 1 should be here. And then it's 0, 0. Watch out for those silly mistakes. 90 and 1 and 180 like that. So now you know. And then what have we got? We've got 270 minus 1 and 360, 0. And so our graph looks like that. So tan is a little bit trickier, but what I love about the calculator is the calculator literally makes this a join the dots puzzle. And then you have to also understand about the shape. So the shape of the tan graph, when you draw the tan graph, you generally draw it in 2 halves. But the logic of this makes sense. Like a whole tan graph now fits in 360 degrees. Between minus 180 and plus 180, we get a whole tan graph. And that's why the period is 360. Okay. Everyone, thumbs up if you're feeling okay, thumbs down if you're feeling a bit lost. Maybe we could squeeze in one more if you're feeling a bit lost. Otherwise, if you're feeling comfortable, we might just be able to end the lesson. It's up to you guys. I want to see how we're feeling. Okay, one more for the road, one more for the road. So let us do this. And I'm going to make it. I want you to draw me the graph of y equals, should we make it cos 2x. Have we drawn that yet? Let's have a look. I don't think we have. Sine 2x, sine 3x. No, we haven't. Okay. So you're going to draw me the graph of cos 2x, and you're going to draw it from minus 180 to plus 180. And again, this is changing the period of the graph because of the 2 in front. Over to you guys. Mdudu, we can do another tan graph. I'll do another one in the next lesson, okay? I'll definitely do another one in the next lesson. So you know when I draw this, it's going to go from here to here. Because there's my start. And here's my end. So okay, so all I was saying was for this question, you just have to draw the graph of y equals cos 2x. And what I've done is I've worked out the period, which was 180. The step size for the cos graph is going to be 45. And now I've got my dots. And so I'm going to join them like this. And you start to see a bit of a predictable pattern because it always goes between, unless there's been an amplitude change, it seems like it just goes between -1 and 1, right? That's the normal cos graph. It's just that it goes up and down more quickly. It's going in steps of 45, not in steps of 90. Now, if I had to do the full exam treatment, I would also label the turning points. So label those turning points and then the end points. This is just like, and then if I called this graph G, I would just call this thing G. Okay, so what I want you to do before Wednesday is I want you to keep practicing drawing trig graphs using a calculator and exploring what happens when you change the number in front of the X. We call this the period change of the trig graph. And then there's one more change that we'll do on Wednesday, which is the horizontal shift, and then we'll also do solving for graphs. Lebo, if I could ask you to just put the poll up. I hope everybody had a good lesson. Don't worry if you're still feeling a bit confused. We keep practicing and we continue on Wednesday. But I wish you well for the rest of the week.